Hi and welcome. I'm trying to learn particle physics, today quarks, and after we've done that, we're gonna do a bit standing yoga, and if you participate in the standing yoga, then it's very outdoors. Quarks are the fundamental constituents of a bulk of matter around us in the form of protons and neutrons, but the fiendish complexities of the interactions via strong nuclear force make calculating the properties of that matter from first principles a task we are only just beginning to master. So these quarks are these protons and neutrons in the universe. But they are complex, and they are interacting via the strong nuclear force, and to calculate them now is difficult. Okay, now to the text. Finnegan's Wake has a reputation for being a difficult novel. Written by James Joyce over 17 years, it blends invented words with real phrases and grammar-defined constructions. Okay. There was James Joyce, and he was writing for 17 years long, and a book which he called Finnegan's Wake, and there were words used which were new invented by him, and also actual phrases, and they were mixed together, and all in a complex way of grammar constructed together, and it makes it hard to read it. The final line ends mid-sentence, only for you to realize that the words which should come next are the ones in the book speak. That is a spoiler. And I read it out. Not really, I stopped by the B. Okay, whatever, there's a little trick in it. Some say it is Joyce's attempt to recreating a dream. Others claim that it contains no meaning at all. It might seem odd, then, that a nonsense word for this most ungraspable of books should have given its name to a building block of reality. Let's see the thing again. It might seem odd, then, that a nonsense word from this might ungraspable of books should have given its name to a building block of reality, the quark. I think I said it in a previous part. I heard two other stories to the origin of quark, and they have nothing to do with this. Maybe one. Maybe the second one is from that book. But the things I read a bit more about it. I don't really know why, but I read more about it. And it was more, it's something else. And not that, but okay. Quarks are as fundamental as anything can be. The constituents of the proton and neutrons that make up the atomic nucleus. These quarks are the protons and neutrons, and they are very important for the nucleus. They are in the nucleus. The electrons are on the outer shells, the protons and neutrons are in the middle. But they are also exceedingly weird, these protons and neutrons. They come in 6 varieties, only 2 of which, up and down, seem to have much to do with normal matter. The electric charge isn't +1 or -1, but fractional values such as +2 third or -1 third. Okay, there are 6 of them, and there are 3 ups and 3 downs. And it somehow makes more or less sense that there are ups and downs, however, but they don't have electrical charge of +1 or -1, which would make sense, but they have +2 third or -1 third or whatever. And they have their own special sort of charge that comes not in the positive or negative variety, but in so-called colors. Now, maybe we're going to learn more about this word colors, which probably everyone who does not know what it means thinks of something else with it is. The origin of quarks lay in the 1950s when more particles were turned up than physicists knew what to do with. Barreling towards us out of the depths of space or summoned into existence by the first particle collider. Okay, in the 50s were these quarks found, and there were just too many and the people didn't understand that. It created a messy zoo of particles of different masses, charges and sizes that seemed impossible to correlate. Whatever it means. Correlate. The insight that would resolve the chaos was developed separately by 3 researchers. Murray Gell-Mann, Yuval Ne'eman and George Zweig. Okay, 3 people. The insight that would resolve the chaos was developed. Okay, 3 people separately, so individually, found out more about these 6 quarks, and these were Murray Gell-Mann, Yuval Ne'eman, and George Zweig. They noticed that many of these particles obeyed a symmetry, suggesting that they were all produced by different combinations of the same core ingredients. What was it? They have a symmetry, and that suggests that they all are produced by different types of combinations, but with the same or of the same core ingredients. Instead of treating the particles in the zoo as fundamental entities, Gell-Mann and the others invented a new set of particles one size smaller. With these quarks in place, Gell-Mann coined the name and got most of the credit. He was the only one to win a Nobel Prize for his work. The mess of particle physics suddenly snapped into order. Okay, there was a new set of particles invented. They had too many particles, they had 20 of them or whatever, and these 6 quarks, whatever, were now by Gell-Mann sorted somewhere in, and now the whole thing made sense again. There were 2 basic possibilities, each of which led to composite particles with either zero or integer charge. You could pair 2 quarks, in fact a quark and an antiquark, of the same but different flavor to make a meson, or you could put 3 together to make a baryon. A proton, for example, was a baryon with a quark composition up-up-down. The neutron was up-down-down. Collectively, the mesons and baryons together, all particles made up of quarks, came to be known as hadrons. And that is the Hadron Collider, named after. No, I think. What was here? There were 2 basic possibilities, each of which led to composite particles with either zero or integer charge. I don't know what an integer charge is. You could pair 2 quarks, in fact a quark and an antiquark, of the same or different flavor to make a meson. Okay, we're having 2, same or different, and that is meson. Or you could put 3 together, and that is a baryon. A proton, for example, was a baryon with a quark composition up-up-down. A proton consists out of, for example, up-up-down, and the neutron consists out of up-down-down. Collectively, the mesons and baryons together came to be known as hadrons. Okay, I think I get it. Now, where's an apple? An apple consists out of molecules, and molecules are all themselves little atoms. And where are the atoms? And an atom has in the nuclei, in the center, all the protons and neutrons, and then on the outer shells, the electrons. And now every of these proton and neutron inside of nuclei has itself again up, up, down, and down, down, up. And these are the protons and neutrons. They consist out of 3 things and 3 things. The introduction of the idea of quarks was revolutionary, says Tara Shears at the University of Liverpool, UK, and also at the university. Still, at first, no one was sure whether quarks were real particles or just a helpful organizing idea. In a 1972 lecture, Gell-Mann himself warned his audience against invoking fictitious objects in our models that end up turning into real monsters that devour us. There were 2 pieces of evidence to suggest that quarks were more than just monsters in the mathematics. First, physicists firing electrons at protons noticed that some bounced off at right angles. When they were taking electrons and fired them against protons. How did we get a single proton when we are in the nucleus? And they were bouncing off at right angles. This suggested that the electrons had hit something inside the proton. Okay, this is interesting. Something like a quark. What's more, Gell-Mann's model indicated that certain combinations of quarks remained undiscovered, like the gaps in Dimitri Mendeleev's original period table of the elements. This gave the model predictive power. When the missing particles formed of combinations of all 6 quarks, up, down, charm, strange, bottom, or beauty, and top, or truth, turned up as expected, the quark model's acceptance was nigh-on guaranteed. Yet much remained unclear. For example, why certain combinations of quarks flourished and others didn't. You couldn't easily produce a composite particle made of 4 or 5 quarks, or even get a quark on its own. Why was this? No, we don't have time. We have to go to yoga. If you were here for particle physics, you can go directly to the next part of particle physics, where we read all at the same place. If you're here for standing yoga, we're going to do that now. If you participate in standing yoga, then it's better to be honest. Feet are standing together. We're breathing in and lifting the arms up. Breathe out the arms out. In the arms up. Out and down. In and up. Out and down. Breathe in the arms up. Out up to the side. In and up. Out up to the other side. In and up. Inch space between the feet. Breathe out onto the side. In and up. Out, sink down. In and up. Out onto the side. In and up. Out and down. In and up. Out the arms over the sides down. Lean onto the knees. Breathe in. Out the heel with the back. In into the middle. Out the belly with the back. Into the middle. Out here. Again in. Out the belly. Out with the round back up and make it to drop it backwards, shoulder roll. Breathe in, lift the arms up. Breathe out open to the side. Breathe in and up. Out the arms over the sides down into the chair. Breathe in, come halfway up. High up. And out and come up. Breathe in, reach high. Breathe out open to the side. In and up. Out the arms over the sides down. We come down into the chair. Breathe in, come halfway up. Come high up. And out. And come up. Breathe in, come up on the tiptoes. Breathe out, sink down. In and up. Out and down. In and up. Out the arms over the sides down. Feet together. And breathe again in. And right leg. And breathe out and stretch your left leg. Breathe in and change. Out and stretch your right leg. In, change. Out, stretch your left leg. In, change. Out, stretch your right leg. In into the middle. And out, just down. Breathe in with the right hand up to the sky. Breathe out with the left knee. Look over the right shoulder to the right hand. Breathe in the hand down. Out and down. Breathe in with the left hand up to the sky. Breathe out with the right knee. Look over the left shoulder to the left hand. In and the hand down. Out and down. Make a hand with space between the feet. Shift the weight to the heels. Breathe in and go down. And out, come up. In and down. Out and up. One more time. In and down. Out and up. Take out on the elbows. And gently jog from side to side. Hands again down. Breathe in, come halfway up with a straight back. Out and down. In halfway up. Out and down. In and come up. Hands together and down. Legs shoulder width apart, intertwine the fingers behind the back and bring them over to one side of the back. Breathe in, turn up, shoulders back. And breathe out, turn the head over to the side with the hands chin down to the clavicle. Breathe again in. And out, pull the arm and lift the shoulder down. In, lift the gaze. Turn the head over to the other side. Hands over to the other side. Breathe again in. And out, chin down to the clavicle. Pull the arm and lift the shoulder down. In, lift the gaze. Back into the middle. Breathe in, lift the arms up. Lift out, lean back. Draw the shoulder blades together. In and up. Up across the arms, intertwine the fingers. Breathe in, reach high. Breathe out, reach from all of the back. In and up. Out, lean back. In and up across the arms again. Intertwine the fingers. Breathe in, reach high. Breathe out, reach from all of the back. In and up. Out and back, drop our shoulder blades together. In and up. And out now, lean the floor arms back. In and up. Out, lean back. In and up. Out the arms down. Breathe in the arms again up. Out down. Breathe in the arms up. Bring the hands to touch. And now then slowly down to heart sit. It was a short and robotic-like fast standing yoga. I thank you very much and until next time.